All right. Hello, grade nines. I hope you're well. I hope you're good, guys. We are going to restart the topic transformation geometry, grade 9. So let's start it from the beginning, from the top. So grade 9 term 4, we have transformation geometry that you guys will be doing, or that maybe some of you have already done. So let's look at it one by one and unpack it. Transformation, what is transformation? Just the word transformation, what does it mean? So the word transformation is a process, okay, by which one figure, expression, or function is converted into another one. Okay, that's the word transformation. A process by which one figure, expression, or function is converted into another one. Then let's look at the word geometry. The word geometry, we know it's just simply a branch of mathematics that studies. What does it study? It studies the properties of what? Of space, including figures, their sizes, their shapes, their relative positions, and the characteristics of space itself. Okay? It explores concepts like your points, your lines, your angles, and your okay. So now let's look at the word transformation geometry itself. What does it mean? So transformations are simply transformation geometry is the study of geometric. So it's the study of geometric transformations, okay, which are simply movements that change a shape's position or size. Okay, this includes translations, which we are going to look at, rotations, which we are going to look at, reflections, which we are going to look at, and enlargements or reductions. Okay, so I repeat again, transformation geometry is simply the study of geometric transformations. What are those? Those are movements that change a shape's position or size. This includes translations, rotations, reflections, and enlargements. Okay. Now, for your what we call rigid transformations, such as your transformations that are like what? Translations. So we are going to look at what translations are. Okay, translation is simply a sliding movement that changes position of an object, okay, whilst not changing its shape or size. What is a translation? It is a sliding movement that changes the position of an object, not necessarily changing its shape or size. I repeat, a translation is a sliding movement that changes the position of an object, not necessarily changing its shape or size. So when we look at translation, we look at translation in terms of the sliding movement of a shape or object left or right. So our translation can either be looked at in terms of the movement of that particular figure, object, or shape left or right. P units. Okay, so the P just means, we could basically represent that P with any real number, but for now, actually with any natural number. But for now, okay, we are going to say P units. Generally speaking, we can either move left or right. 2, we can either move up or down. And when I talk about up and down movement, I'm going to refer to it moving Q units. So this is general, okay? Guys, we'll look at specific examples, but for now, I just need you to understand that when we talk about transformation, grade 9s, when we talk about transformation, We are talking about transformation in terms of translation. And what is translation? It is a sliding movement that changes the position of an object and not necessarily changing its shape or what? Or size. Okay? And so translation can be looked at in terms of movement of the object left or right, which is p units left or right, or we can say q units up or down. That is translation. Translation can only be seen in terms of the movement of a particular figure or shape, left or right, or up or down. Then we have another type of transformation, which is called rotation. What is rotation? Rotation is a turning movement around a fixed point by a certain angle. I repeat, rotation is a turning movement around a fixed point by a certain angle. Okay? All right, that's rotation. 3, we look at reflection. What is reflection? Reflection is simply a flipping or mirroring movement of an object across a line. I repeat, reflection is a flipping or mirroring movement of an object across a line. That's what reflection is, grade 9s. Reflections is a flipping or mirroring movement of an object across a line. Then lastly, we look at enlargement. What is enlargement? Enlargement is when we expand a particular object or when we reduce or dilate a particular object or shape. Okay? And we usually talk about a particular scale factor or K factor that particular object is either enlarged or reduced. So what is enlargement? It is a process that changes the size. I repeat, enlargement is a process that changes the size of an object by either increasing that particular size of the object, in other words, enlarging it, or decreasing, in other words, reducing by a certain scale factor. Okay, so we usually say that the original shape and its image is similar, right? Okay, so we say the scale factor K is the number multiplied or what? Or divided by the coordinates of each point to what? To form an enlarged or reduced image of the original shape. Okay, let's look at this again. What is enlargement? Enlargement is a process that changes the what? The size of a what? Of an object by what? By increasing, enlarging, or decreasing, reducing, by a certain scale factor. So what we say is that the original shape and its image is similar. Okay. The scale factor K is the number multiplied or divided by the coordinates of each point to what? To form an enlarged or reduced image of the original shape. So guys, I hope we see this, that when we talk about transformation geometry, we are going to look at transformation geometry under these 4 headings. Translation, which is the movement or sliding movement that changes the position of an object, either left or right, up or down. Rotation, a turning movement around a fixed point by a certain angle, that's a rotation. Then we're going to look at it in terms of reflection, a flipping or mirroring movement of an object across a line. And then lastly, enlargement, which is basically the increase or the decrease of the size of an object by a certain scale factor. Okay, so let's now turn our attention to what we will be learning under this topic. So under transformation geometry, we are going to look at, guys, we will learn how to recognize transformation. We're going to learn how to recognize the transformation of a point, okay, or a line segment, or a simple geometric figure. It's very important to understand this, that we're going to look at transformation in terms of how a point is affected, how it changes, how a line segment changes or is affected in its change or movement, and then lastly, how a simple geometric figure is affected in its movement or its transformation. Then 2, we're going to describe the transformation of a point, of a line segment, and of a simple geometric figure. So we are not only just going to recognize the transformation, but we are going to learn how to describe the transformation, okay? Then 3, we are going to also learn how to perform transformation of a point, of a line segment, and of a simple geometric figure. Very important. So these 3 things, these are the objectives that we need to accomplish by doing or learning transformation geometry, grade 8s and grade 9s. Okay? Need to learn how to recognize transformation in points, line segments, and in geometric figures, how to describe transformation in points, line segments, and geometric figures, how to perform transformation in points, line segments, and geometric figures. Okay, let's move. Now, we need to learn what is a point. What is a point? A point is a dot, uniquely defined by an ordered pair, x and y. This is what we call an ordered pair. Okay, so a point is a what? It's a dot that is uniquely defined by an ordered pair, x and y, where the x coordinate represents the horizontal position. I repeat, where the x coordinate represents the horizontal position from the origin, and y, the y coordinate, represents its vertical position from the origin. So I repeat, what is a point? A point is a dot that is uniquely defined by an ordered pair, x and y, where x, the x coordinate, represents the horizontal position from the origin, and y, the y coordinate, represents what? Its vertical position from the origin. Okay, that is what a point is, guys. Okay, because remember, we need to recognize transformation of a point. If we don't understand what a point is, then how are we going to recognize its transformation? So what is a point? A point is a dot that is uniquely defined by an ordered pair, x and y, where x, the x coordinate, represents the horizontal position from the origin, and the y coordinate represents its vertical position from the origin. 2, what is a line segment? A line segment is a finite position, a finite portion. Okay, when we say finite, it means there's a beginning and there's an end. You know, it's not infinite. When we say finite, finite is a word that denotes that something has a beginning, it has an end. So sorry about that. Line segment, a finite portion. Why do I say position here? A finite portion of a straight line defined by 2 distinct endpoints. Okay, I repeat, a finite portion of a straight line that is defined by 2 distinct endpoints. So there's x1 and y1, which is the end the beginning of the line segment, and x2 and y2, which is the end of the line segment. It has a length unlike an infinite line. So we can actually calculate the length of a line segment because the line segment has a beginning point and an end point. So that means it has a length that we can measure that line segment. Okay, it can be measured. That is what a line segment is. So we've defined what a point is. We've defined what a line segment is. Hopefully we understand what those two things are. Now lastly, what is a simple geometric figure? A simple geometric figure is a two-dimensional shape. Two-dimensional shape. By 2D, guys, we mean that there's a vertical dimension and a horizontal dimension. So geometric figures are two-dimensional shapes such as a what? A line, circle, square, triangle that is located, okay, on a Cartesian plane. CP means Cartesian plane, using coordinates or any other 2D drawing with ordered pairs. So what is a simple geometric figure? A simple geometric figure is a two-dimensional shape such as a line, circle, square, or triangle that is what? That is located on the Cartesian plane using coordinates or any other 2D drawing with ordered pairs. Guys, so any two-dimensional shape that we can see on the Cartesian plane, we refer to that as a simple geometric figure. That's what's important here to note. Then lastly, what is a Cartesian plane? Maybe some of you are going to be like, what is a Cartesian plane? So when we did functions, hopefully guys, when you did linear functions, you were able to see what a Cartesian plane is. So just for those that may not know, a Cartesian plane is simply a flat two-dimensional surface divided into 4 quadrants by 2 perpendicular lines, a horizontal x-axis and a vertical y-axis. So I'm hoping guys we all know what a Cartesian plane is. There's that y-axis, there's that x-axis. This is what a Cartesian plane. There's positive x values, the origin is there. This is what we mean by the origin. There's 1, 2, 3, 4, 5 positive numbers, -1, -2, -3, negative numbers for x, then here positive numbers for y, and then negative numbers for y. So hopefully we know what a Cartesian plane is. Divide into 4 quadrants, first quadrant, second quadrant, third quadrant, and then fourth quadrant. This is what we mean by quadrants of a Cartesian plane. Okay. So hopefully we are all together so far. First quadrant, second quadrant, third quadrant, fourth quadrant. That's what we mean by Cartesian plane. So I repeat again, a Cartesian plane is a what? It's a flat two-dimensional surface divided into what? 4 quadrants. Quadrants. Okay. By 2 perpendicular lines. Here's your vertical y-axis, which is perpendicular to your horizontal x-axis. That's why they say 2 perpendicular lines, your horizontal x-axis and your vertical y-axis. This is what we mean by Cartesian plane. And then we have it divided into 1, 2, 3, 4 quadrants in a anti-clockwise direction. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay. So hopefully we are together so far and we are good. Okay, now let's jump into the first type of translation, which we refer to as, first type of transformation, which we refer to as translation. Let us unpack, guys, what do we mean by translation? So translation that is within and across quadrants. what do we mean by translation that is within and across quadrants? So, as I had said earlier on, translation can be looked at in two ways. The first type of translation is when we look at the movement or the sliding of a line, point, or a simple geometric figure to the left. If we are talking about the movement of that geometric figure to the left or to the right, this is our first type of translation that we are talking about. The object can either move to the left or to the right. So if we look at an example here, let's say we have a point. So this is rightfully a point, point A, which has the x and the y coordinate. If we say that this point A moves to the left, this is how the movement to the left affects the point. First and foremost, when we say to the left, then we mean that our x coordinate is the one that is going to change. Movement to the left or to the right means our x coordinate is the one that is affected. So who is affected? X. How? So if we say we moved, let's say, p units to the left, then it means the image of A. So we write A, the image is x. So our x is affected. But then since we say to the left, it means we are going to subtract from x. We are going to do what? Subtract from what? From x. So we are going to say x minus p. Okay, since we are saying p units to the left. So let's just say it said p units to the left. Remember, p can represent any natural number. By natural number, 1, 2, 3, 4, 5, we mean, okay, we mean that. So if we say p units to the left, then it means our x coordinate is going to change the image of A, which is from the original A, the image of A, the new coordinate of A, the changed, transformed coordinate of A. We are going to say x minus the p units to the left. So it's x minus p. And then our y coordinate is going to stay the same. So x is affected. We subtract from x, y stays the same. Okay, y doesn't change. So who changes? X. How? We subtract the units from x to form the new image of the new point, A image, which is x minus p, but the y value stays the same. Let's say they are talking about translation to the right by p units. If they are saying translation to the right by p units, our coordinates, the point A, which is x and y, how is it going to be affected? So once again, x is going to be affected. How? If we are saying 3 units to the right, then it means our x coordinate, we are going to add to our x coordinate the number of units that the point moved to the right. We are going to do what? Add to x. So we add 2x, okay, whilst y stays the same. Okay, makes sense, guys? Hopefully so far we are going together, we are moving together. So to the left, we subtract. To the right, we add. Okay? To who? To x in both situations. Okay? Because horizontal translation or horizontal movement affects the x coordinate. Okay? So this here, to the left or to the right, this is speaking to horizontal translation. Okay? And as our x-axis is horizontal, it's x that is affected for horizontal movement to the left or to the right. Okay, let's move on to the second type of translation, which we refer to as vertical translation. Now with horizontal translation, we can either move up or down. Up or down. We can move up by q units. Okay. Now obviously if we are going up by q units, okay, then it means our point x and y, who is affected first and foremost? This time round it's not x that is affected, but it is y that is affected. Up movement affects y, down movement affects y. Okay. Up movement affects y, down movement affects y. Now with our up movement by q units, it means that we are going to add, if we are saying moving up, we are going to add q units to the y. If we are moving down by q units, guys, then it means we are going to subtract q units from y. Okay, so up we add to y, down we subtract from y. Okay, yeah, hopefully that's clear for all of us. Okay, so that is translation, guys. That pretty much wraps up the concept of translation. Okay, so up movement will affect y, down movement will affect y. By q units, then obviously up, it means we add q to y. Down by q units, it means we subtract q from y. Okay, yeah. Okay, let's look at this activity quickly. Activity 1. The following activity says, translate the following points according to the rule in brackets and write down the new coordinates of the image. Okay. So here we have a point A, 1 and 3, and we are told it 3 units to the left. Okay, so what is the new image of A if we are saying it moved 3 units to the left? Okay, you guys can let me know in the comment section. 3 units to the left, what does that affect first and foremost? Who is going to change? And then ultimately, how is it going to change? And lastly, what is the new coordinate of A? So that's A, 1 and 3. Image, 3 units to the left. What does that mean, guys? 3 units to the left. Who are we affecting if we are saying 3 units to the left? Who are we affecting? Are we affecting X or Y? Who is affected? Okay. So Alika says X, the X value will be affected. The X coordinate, okay? The X coordinate will change by -3, Babeska Forever says. All right. So you guys are 100% correct. To the left means our X coordinate will be affected. And remember, to the left means what? Remember, to the left means that our X value we subtract from what? From X. Y will stay the same. So rightfully so, we say 1 minus 3. Okay, and then our Y coordinate stays the same. So therefore that means our changed A value, 1 minus 3 is -2 and 3. So this is the image of A. Okay, it's -2 and 3. Very good. Thank you so much, Alika and Babeska Forever. Let's move on to the next one. B, -3 and 0, 2 units to the left. So once again, who is affected, X or Y, and how? Who is affected and how? These are very important, these questions that you ask in your head. Who is affected? The minute you read this, you ask yourself, who is affected? X or Y? Then 2, how then is that X or that Y affected? Once you are able to identify the X or the Y, how are they affected? You know, and then you apply the relevant effect to the relevant point. So there's a transformation there. The image of B, 2 units to the left. Yeah, hopefully you guys are doing it yourselves. So okay, 2 units to the left means minus 3 minus 2. X is affected, okay, and we subtract 2 units, okay, because remember 2 units to the left, so that means minus 2 to the negative 3, okay. Yeah, let's be very careful while X stays the same. So that means the image of B will be negative 5 and 0, okay. Very good, babes go forever. I mean, yeah. Then number 3, C, negative 2, negative 2, 5 units to the right. So once again, who is affected? X or Y. Then 2, how is X or Y affected? If it says 5 units to the right. So firstly, who is affected? And how are they affected? If we're saying 5 units to the right. Image. Okay, X is affected by plus 5. Thank you so much, babes. So we have minus 2 plus 5. Very good, guys. You guys are 100% correct. And then our Y value stays the same. It's negative 2. So that means the image will be 3 and negative 2. That is our new point. Okay, very good. Very, very good. Next one. D, negative 1 and 2. 1 unit up. D, negative 1 and 2. And it says 1 unit up. 1, who is affected? 2, how are they affected? So 1 unit up, that speaks to vertical translation. Okay, Y is affected by plus 1. Very good, very good, very good. I like her. Yes, I see you there as well. Y is definitely affected. So we say D, the original, the transformation, the image of D. So Y is affected. We say 2 plus 1. Then that means the image is negative 1 and 2 plus 1 gives us 3. Okay, there we go, guys. Then 5. E, negative 1, negative 3, 4 units down. Who is affected and how? 4 units down. Who is affected and how? I like her. Y is affected by minus 4. Very good, guys. Yeah, you guys are like phenomenal people there in the comment section. Very good. The E, the image, negative 1, negative 3, 4 units down, minus 4. Okay. So that means the image is negative 1, negative 7. Okay. Very good. Very good. Very good. Okay. So we are able to see here, guys, how this translation thing works. The application of translation. Okay, the application of translation, which is very important. Application of translation, no problem. Okay, so we're able to see that with a point, how we are able to get a point from our translation. Okay. Okay, now let's go to a slightly different scenario. If we look at the scenario, it says describe fully the single translation that maps triangle A onto triangle B. Once again, it says describe what? Fully the what? The single transformation that maps triangle A onto triangle B. So what we want to do is we want to describe the transformation that has happened that maps. So we want to look at what happened to triangle A so that we get B. So the wording here is describe fully the single transformation that maps triangle A onto triangle B. Okay, so all of this wording maps. Okay, we just want to basically see what happened to triangle A so that we get it to the position of triangle B. Okay, so we're still looking at transformation, specifically translation. So there's a few things you can do, right? Is you can look at the vertex of the triangle. Okay, you can either look at this vertex and you can check what happened. Okay, this vertex complements that one. So what you can do is you can move, okay, in this direction first and foremost. So if we move in this direction, in what direction are we moving if we move in this direction? Okay, because this is a horizontal movement. Okay, this is to the what? To the left or to the right, guys? In this direction, is it to the left or to the right? So we can look at a vertex at a time. Yes, I like it. It's to the left. So if we look at where this vertex is, it's at -3. So if we jump once, we are at -4, that's 1 unit. Jump twice, we are at -5, 2 units. We jump 3 times, we are at -6, that's 3 units. So directly above, okay, this triangle B, we moved how many units to the left? 1, -4, 2, -5, 3, -6. So we've moved 3 units to the left. This is the description. Then remember, we're still talking about this vertex which complements that one. Then we are going to move up as well. We want to check how many units we move up. So where are we at the moment with y? We are at +2. And where is this triangle at as far as this vertex? It is at +6. So from 2 all the way to 6, how many units is that? Okay, 6 to, from 2 to 6, how many units is that, guys? How many units are we going to be moving up by to get to that vertex? How many units, guys? Okay, I'm going to allow you guys to tell me how many units from 2 all the way to 6. Very good, Alika. It's 4 units. So it's 1, 2, 3, 4. So we are saying 4 units up. So we've just described the transformation of A to B. 3 units to the left, 4 units up. Now guys, something very important is that, remember, I used this vertex to describe the transformation, but you could use this one as well. Okay, remember, this one complements that vertex. So what you want to do is you want to check how many units. 1, -2, 2, -3, 3, -4. That's directly above that vertex. So it's 3 units to the left. Still 3 units to the left. Then from this point, from 2 up until 6 still is 4 units up. So you can use this one as well. Let's look at this vertex. Can we use this one? Yes, we can. This vertex complements that one. Okay, so this vertex If we do the same thing to the left, 1, 2, 3 units to the left. Then to that vertex, how many units? From what? From 3 to what? To 7. That's 4 units up as well. So what I'm saying to you is that to describe the transformation of a geometric shape, you can use any of the vertexes and basically see the corresponding vertex, okay, the corresponding vertex, and basically move towards it, okay. So I hope we are all together here, that the movement of A mapping onto B is 3 units to the left and 4 units up. We've just described fully the single transformation that maps triangle A onto triangle B. Remember, this question could have been asked in reverse. They could have asked, describe fully the single transformation that maps triangle B onto A. What would we have done if they had said, describe fully the single transformation that maps triangle B onto A? Then we would have basically looked at what's happening from B to get to A. So you could look at this vertex, okay. So it would be 1, 2, 3. 3 units to the right, and then 6 to 2, 4 units down. Do you see that? So if it had been describing the transformation of triangle B to A, then we would have basically looked at that type of transformation. 3 units to the right, 4 units down. Okay? So hopefully we understand, guys, that if the question asks in a certain way, then we ought to ensure that we are able to answer the question whatever the situation is. Can I move on? Are we all good? Do we see what it means to describe the transformation? In as much as we are able to do calculations so that we can get the points, but also do we see how to describe the transformation and how we go about it? Can I move on, guys? Alika, can I move on? Babes Forever, can I move on? Are we good? Do we need more time? Do we need more explanation? Do we have any questions so far? I want to move on to the second type of transformation. So we've looked at translation. Now we're going to move on to another. Okay, all right, let's move on to the next. Okay, let's do this. Let's just one more. Think whilst we're still here, let's do this. Write down the coordinates of the vertices triangle A, B, C, if triangle A is translated 6 units to the right and 1 unit down. So I just want to look at this, guys. So here we are asked to write down the coordinates of the vertices of this triangle ABC. If triangle A is translated 6 units to the right and 1 unit down. So where's triangle A? There's triangle A. So first and foremost, what you are going to do, A, B, C. Let's first go and identify the current coordinates of A, B, and C. So let's look at A. What are the coordinates of A? In the comment section, you guys can let me know. What are the coordinates of A from what you can see? What what are the coordinates of A? What are the coordinates of A, guys? Okay, be very careful there. Sorry. Yes. Sorry if you can't see properly. Yes, I like it. It's -3 and... Is it -3 and 2? Are you sure about the 2? Coordinates of A? I agree with the -3, but I don't agree with the +2. It's not -3 and 2, guys. Yes, I like a -3 and 3. Very good, very good. Sorry, guys. Just need just a sec. I'm coming back. Okay, very good. It's -3 and 3. A is -3 and 3. Then B. What are the coordinates of B? There's B, guys. What are the coordinates of B? Because it's very important to know how to identify coordinates. It's a skill we need to have, and we need to have it very well. Coordinates of B? What are the coordinates of B, guys? X, Y. Yes, Malika, -3 and 2. And then what's the coordinates of C? I agree with you, Malika. Then, like, and then coordinates of C? -1 and 2. Very good, I like. I think Alika is like the only one that's really proactive here. So -3 and 3, that's A. Then B, we have -3 and 2. And then C, we have -1 and 2. Okay. Remember, it said write down the coordinates of the vertices of triangle ABC if triangle A is transformed 6 units to the right and 1 unit down. 6 units to the right, 1 unit down. 6 units to the right, 1 unit down. So 6 units to the right and 1 unit down. So 6 units to the right, who is affected and how? Then 1 unit down, who is affected and how? So that we can apply that effect to all 3 of these coordinates, so that we can know what are the newly formed images of A, B, and C. Six units to the right. One unit down. Yes, very good, Alaika. So that means our first A image is going to be 3 and 2. Image of B is going to be 3 and 1. And then image of C is going to be 5 and 1. Okay. Yeah. So there it is, eh? Those are our images. And then if they say plot, okay, triangle, plot the new triangle, then we must be able to plot the new triangle using our new points. So 3 and 2, x is equal to 3, y is equal to 2. There it is. So 3 and 2, this is the point. 3 and 2. 3 and 1. 3 and 1. There is the point. 3 and 1. Then lastly 5 and 1. 5 and 1. There is the point. 5 and 1. Okay. And there it is, guys. That would be basically the new image that is formed. Okay. Yeah. So hopefully we see this. Okay. Yeah. Because if they say plot the new triangle, we need to be able to plot the new triangle using the newly formed coordinates. Okay. So the A image 3 and 2. B and then C. So that is the triangle. Okay. Exactly. So please, guys, this transformation geometry, there's nothing much to it. Okay, especially the translation part of it. So we need to make sure that we understand that if we are talking to the left, we are subtracting from P. To the right, we are adding to P. Up, we are adding P to X if we are to the right. To the left, we are subtracting P from X. Then if we are talking about up movement, then of course up movement means, and then down movement means that affects Y. Okay, let's move on to the next type of translation. Okay, which is what? Reflection. Okay. Reflection. Okay. So reflection, we can look at reflection under 4 headings. There's reflection in the x-axis. 2, reflection in the y-axis. 3, reflection in the line y is equal to x. And then 4, a reflection in the line y is equal to negative x. Okay, so we're going to look at these individually. When we're talking about reflection in the x-axis, guys, here's something else to note, that the line y is equal to 0 is the same thing as the x-axis. The equation of the x-axis is the line y is equal to 0. Very important. Okay. So if they say reflection in the x-axis, you must understand that it is the same thing as saying reflection on the line y is equal to 0. It's one in the same thing. Yeah, but one in the same thing. So reflection in the x-axis or the line y is equal to 0, okay, means the same thing. Okay. Then reflection in the y-axis. The y-axis has an equation of x is equal to 0. Okay. So these mean the same thing. So don't be lost the minute they say the line x is equal to 0. It is the y-axis, guys. It is the same thing, right? Then reflection in the line y is equal to x, and then reflection in the line y is equal to negative x. Okay. Now let's go and look at the specifics of the affected change Who is affected and how? Okay, who is affected and how? So if I say we are reflecting in the line y is equal to 0 or the x-axis, this is what we need to understand. If there's a point and it's x, it's a, which is x and y, the minute we reflect in the x-axis or the line y is equal to 0, this is what happens. Y is affected. And what happens to y? There's simply a change of the sign of y. So if y was positive, it simply changes to negative. If y is negative, it simply changes to positive. That is the reflection in the x-axis or the line y is equal to 0. Okay, are we together, guys? In the comment section, are we following that reflection in the x-axis or the line y is equal to 0 simply means this: y is affected. How? There's simply a change of sign of y. That's all that means when we are reflecting in the x-axis or the line y is equal to 0. Okay. And guys, just to make sense of this, this is the x-axis on our Cartesian plane. Okay, when we are reflecting along this line, it means the mirror image is on this side. Think about it practically. Here on this side, our y value is positive. But all of a sudden, if we reflect on this side, our y value changes from being positive to what? To being negative. That's why we say that reflection along the x-axis means that y is the one that changes. It makes sense because y here on the top is positive. Our y values here on the y-axis are positive. But the minute we reflect on this side, our y values stop being positive, but they become what? Negative. That's why when we talk about reflection along this x-axis, we talk about the change of y. It's y that is changing, okay? Not x, but y, because we are reflecting along this line. You see? X will stay the same. It's not going to change. X is going to stay the same if we're reflecting along this line. But y is going to change sign. Okay? If the image was this side, if it reflects along the x-axis, it becomes here. You see, the y is going to change. Y is ever changing when we are reflecting along the x-axis. I need you to understand this in light of the diagram, but also in light of the theory that we have. So reflection in the x-axis or the line y is equal to 0 means what? It means our y value is the one that changes. Change of sign of y. That's what happens when we are reflecting in the what? In the x-axis. Or if they say the line y is equal to 0, they may say in the question, reflection along the line y is equal to 0. And when you need to understand, oh, the line y is equal to 0 is the x-axis. Who is affected? Y. How? Change of sign. You see? Now let's move on to the next one. 2. Reflection in the y-axis. What does reflection in the y-axis mean? Or the line x is equal to 0. Reflection in the y-axis or the line x is equal to 0. Okay. This is A. This is the image. What happened? There's a change of sign of who? Of x. So who is affected when we reflect along the y-axis? It is x. It is x that is affected. Okay? How? A change of sign in x. Practically speaking, what do we mean by this? Guys, this is your y-axis. Okay? The line x is equal to 0. Okay? This is your y-axis. The line x is equal to 0. So if you think about it this way, if your image is this side, and then it reflects to become this side, what does that mean? It means there's a change in sign of who? X this side is negative. X this side is what? Positive. So there's a change in x. But our y value, it will stay the same. So hopefully we are together here as well. Okay. Yeah. Once we get this, guys, very well, then it will be fine. No, 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 no. This here is not the reflected image. Whoever. Okay. This here is not the reflected image. I'm just saying that if we take this here and reflect it along this y-axis, guys, then what's going to happen? It's going to be x that will change. Okay. This here, no, this is not the reflected image. I've just come to this Cartesian plane. I just want to make the point that as the x values here are negative, if you are going to come this side, the x values are positive. So reflection along this axis, the y-axis, means that the sign changes for who? For x. Okay, I was just making the point. Otherwise, this is not this is not the image that is reflected. Okay, so reflection in the y-axis or the line x is equal to 0 means who? It means x changes. Okay, the sign of x, change of sign of x. Okay, then let's go here. Reflection in the line y is equal to x. Okay, a reflection in the line y is equal to x. Okay, now I need you guys to understand what we mean by a reflection along the line y is equal to x. So this is the line y is equal to x. Okay, so when we reflect along this line from here to there, okay, this is reflection along the line y is equal to x. This image would be a reflection of that image there. Okay, what does it mean when we're reflecting along this line? If we are reflecting along this line, guys, this is what it means. Reflection in the line y is equal to x simply means that there is a swap. X becomes y, y becomes x. Okay. So we swap these around. Okay, so we swap x and y. Okay, that's the new image reflected along the line y is equal to x. The inverse. Okay, so y becomes x, x becomes y. That's what we mean by a reflection in the line y is equal to x. Okay, and then lastly, reflection in the line y is equal to negative x. So what we do here, guys, is that we swap and we change the signs of both coordinates. We first swap, we change both signs. I'm sure you can see x and y here is swapped, and then look at the signs, they have both changed. Okay, that's a reflection in the line y is equal to negative x. Okay, I need you guys to understand these reflections, all of them, because when you are asked them, you must be able to answer them. And I'm doing all of these reflections so that you have them and you know them and you can apply them. Okay, okay. So I'm giving you that additional information. Okay, and these are important translations that you need to know, guys. You need to know them, right? Because if you are going to grade 10 next year, okay, it will assist you to know these things, because you're going to do functions in more depth in grade 10 as a pure math student. So if you understand the translations very well, you're going to see how nice and beautiful even your understanding of functions will be. Okay, you're welcome, Ojo. You're welcome. I'm glad I could assist. Oh, and thank you for the gift as well. I think I saw someone send, I don't know if it was an ice cream or a rose, but I'm sorry, I didn't acknowledge it at the time, but thank you so much for, yeah, I think it was an ice cream. Thank you. So yeah. These are the reflections that you need to know. Okay. Yeah. I think if you know the reflections very well, then you are good. You are good. Okay. Any questions about the reflections? Any question at all? Okay, I just want to show you this. This is a good typical example. This is a reflection. Look at this teddy bear. A reflection along this vertical line. Okay, this teddy bear here is reflected along this vertical line. Look at it. Look at it. You see? Reflected along this vertical line. This would be typical of reflection along the y-axis, or in other words, the line x is equal to 0. And the one who would change here is who? The x value would change, right? The x value would change because we are reflecting along a vertical line. Make sense? Yeah. Look at this one. This is a reflection along this horizontal line. This rhinoceros here is reflected along this horizontal line. Do you see that? Yeah. So this is what we mean by mirror reflection. Imagine you were standing here. The rhinoceros was, well, yeah, y will change. Very good. This rhinoceros is standing and is looking at the water. And look at the water there. As it looks into the water, it's seeing a mirror reflection of itself. This is reflection, guys. Reflection along the horizontal line. This is reflection along the vertical line. Do you see this? So here x is changing, y is changing. X is changing, y is changing. You see? X is changing, y is changing. We good, ne? Yeah, I hope we are good now. Yeah, this would be a typical, whatchamacallit, a typical image of reflection. Okay, along that x-axis and y-axis, as we were saying. Okay. Okay, then look at this one. Remember? This here is a reflection along the line y is equal to x. You see? This is the reflection along this line y is equal to x. And remember, what did we say about the y, the x and the y coordinate when we're reflecting along this line? We said that there will be a swap. A swap in what? In y and x. Remember, y and x simply swaps around because they are reflected along this line y is equal to x. Okay? Yeah, so that's kind of like a visual, so that you guys can have a sort of like a visual, take of what we are doing here. So that it's not like completely yes babes, yes, that's the one. Forever. Okay. All right, so hopefully that's clear. Clear as daylight. Okay, let's look at an example. Let's say we are given the points A, 0 and 1, B, 1 and 2, C, 2 and 3, D, negative 1 and 2, and then E, negative 3 and 1. Okay, number 1, sketch the points on a Cartesian plane. You think you guys can do that for me? Sketch these points on a Cartesian plane. Can you do that for me? Draw a Cartesian plane and then sketch these points. That's the first question. 2. Then please determine the coordinates of A, B, C, D, and E image reflected about the line y is equal to 0. And then 3. Okay, can we sketch these points, guys? A, 0, 1, B, 1 and 2, C, 2 and 3, D, negative 1 and 2, and then E, 3 and 1. Let's sketch the points as they said. 2, can you then determine the coordinates of the image of A, B, C, and D, and E reflected about the line y is equal to 0, okay? We need then the reflected points about this line, and then 3, again, reflected about the y-axis. I need the points of A, B, C. Okay, then again here reflected about the line y is equal to x, A, B, C, D, E. Then I need you guys to sketch the points A, B, C, D, and E on the same Cartesian plane. On the same system of axes, we would say. Okay, if we say same system of axes, we are saying the same Cartesian plane, in other words. Okay, so let's go, guys. Let's go, let's go. Okay, 0 and 1, guys. 0 and 1. X is 0. X is 0 is everywhere on this vertical line. Then y is 1. That's exactly there. So A, that's where A is. 0 and 1. Okay. B, 1 and 2, where x is 1. X is 1 is everywhere on this vertical line, everywhere. X is 1 is everywhere on this vertical line. Then y is 2. Y is 2 is everywhere on this horizontal line. Where do they meet? They meet there. Okay, so that's B. Okay, that is B. Okay, x is 1, y is 2. That's where they meet. X is 2, y is 3. X is 2 everywhere on this vertical line. Y is 3. Okay, so there it is. Okay, that's C. Then D, x is negative 1, y is 2. X, negative 1, everywhere on this vertical line. Y is positive 2, everywhere on this horizontal line. Where do they meet? And lastly, E, 3 and 1. E, 3 and 1. X is 3, there it is. Oh, is it negative 3 and 1? Sorry. Yeah, sorry, it's negative 3 and 1. Sorry, negative 3 and 1. Okay, so x is negative 3. There it is. Okay, everywhere on this vertical line. Positive 1. There we are. So there we are meeting. Okay. Negative 3 and 1. 0 and 1. Negative 1 and 2, B 1 and 2, C 2 and 3. Okay, so those are my points, guys. I've the points on the Cartesian plane, there they are. I've represented all of them and they are 100% accurate and correct. Hopefully you also were able to represent all the points 100% correct and accurate. 2, determine the coordinates of the image of A, the image of B, the image of C, D, and E reflected about the line x is equal to 0. What is this, guys? X is equal to, not x, y is equal to 0. What is this? Okay, this is a reflection along the line y is equal to 0. But what is this actually? The line y is equal to 0 is what we refer to as our x-axis. So we are reflecting along the x-axis, in other words. What does that mean? Who is affected and how? You still remember who is affected and how? If we are reflecting along the x-axis, who is affected and how? Do you still remember, guys? Reflection in the x-axis or the line y is equal to 0. What did we say? We said who is affected? Y is affected. How? There's a change of sign in y. That's all that simply means. Okay? Okay. Yeah, let's... No, not x. Y is affected, guys. Reflection along the line y is equal to 0. Remember I said the line y is equal to 0 is the same thing as the x-axis. If we are reflecting along the x-axis or the line y is equal to 0, then it means that who is affected? Y is affected. How? There's a change of sign in y. Because remember, the line y is equal to 0, guys, is the x-axis. And remember, what did we say? Who changes if we are reflecting along this line? It is y, guys, that is changing. Please don't forget that. Otherwise, you're going to sabotage yourself. Okay? Okay, so... let's go ahead and write down the points and the reflection. So A, we know is what? A is 0 and 1. The image that is reflected is 0 and negative 1, obviously. Okay, change in y. B, what is the coordinates? 1 and 2. The reflection along the x-axis. It is very true. Thank you, Alaika. 1 and negative 2. Very good. C, 2 and 3. The image Thank you, Alika. Alika is like so fast there in the comment section with the typing. 2 and negative 3, very good. D, which is negative 1 and 2. The image of D reflected along the x-axis. Thank you, Alika. Negative 1 and negative 2. E, negative 3 and 1. The image 3 and negative 1. Then that's it. Okay, we are good. The reflection along the x-axis or the line y is equal to 0. Let's not forget that, guys. We can say reflection along the line y is equal to 0. This is the same thing as the x-axis, the same thing. And we need to understand there's always a change in y that is affected in the sign change. Okay. Next question. Reflected about the y-axis. Okay, guys, reflected about the y-axis. Okay, we need to look at the same points, but this time as they are reflected about the y-axis. Okay, same points reflected about the y-axis. So who is affected and how when we are reflecting about the y-axis? Yeah, x values are affected, definitely. Okay. Okay. A, 0 and 1. So if we're going to reflect about the y-axis with 0 and 1, okay, what are the coordinates? I'm sure you shouldn't be surprised. 0 and 1. The number 0 is a neutral number. Okay, very neutral. So the image reflected about the y-axis, yes, Nwabisa, very true. Still 0 and 1. Okay. B, 1 and 2. The image of B reflected about the y-axis. Yes, Alika. Yes, vegan. Yes, babes. So negative 1 and 2. Very good, mummies. Okay. Then C, 2 and 3. We're still reflecting about the y-axis here. So the image of C, yes, negative 2 and 3. D, the image of D reflected about the y-axis. Yes, Alika. Yes, Nwabisa. Yes, babe. So 1 and 2. Then E, negative 3 and 1. The image of E, yes, babes. No, Alika. Yes, super not angel. So we have 3 and 1. Okay. Sweetest. All right. Moving on to the next question. Reflected along the line y is equal to x. We want the image of A, image of B, C, and D, and E for when we are reflected along the line y is equal to x. So reflected along the line y is equal to x. I have A, 0 and 1. The image, guys, of A, if it's reflected along the line y is equal to x, what do we have there for A, the image? If we are reflected along the line y is equal to x, remember, what do we mean by reflection along the line y is equal to x? Yes, Megan? Yes, super not angel. You guys are 100% correct. Yeah, here we swap, right? We swap the x and the y so that we get the image of the point. Okay. B, 1 and 2. The image yes, Alika, yes, babes, yes, super. Okay. C. I guess Nobisa, you joined late. A reflection along the line y is equal to x means that if you had a coordinate that is x and y, the image of A becomes y and x. In other words, we swap the x and the y coordinate if we are reflecting along the line y is equal to x. That's what reflection along the line y is equal to x actually entails. Okay. All right. And then diagrammatically speaking, if you guys look at this image here, okay, this is the line y is equal to x. If you are reflecting this triangular object image here along this line y is equal to x, what happens is that A compared to the image of A, you're going to find that this point and this point, okay, the x and the y have been swapped around. This point and that corresponding point, this point and that corresponding point, the image of the two objects is the swapping of the x and the y value around. Okay. Yeah. So okay. So back to the points. B1 and 2, C. Okay, C, no problem. Okay, then our C coordinate. I think I saw in the comment section, I saw people did comment about the image of C. So it's 2 and 3. Thank you, Super Not Angels. Obviously, yes, it's 3 and 2. D, negative 1 and 2. Yes, guys, it's 2 and negative 1. Then E, negative 3 and 1. E, the image. Yes. 1 and negative 3. Okay. Yeah, so I think we we pretty much got this down. Then last but not least, they said we need to sketch 4. So we need to sketch what we got here on the same system of axes. On the same system of axes. They want us to sketch that, okay? Yeah, and I'm sure you guys will be able to see that. Oh, okay. If we come here and draw on the same system of axes, then this makes sense. Okay. A was 0 and 1. Okay, the image of A is actually 1 and 0. Here is the image of A. Okay, I just want to reveal this line y is equal to x so that you guys can appreciate that, oh, really reflected along. Okay, B was 1 and 2. then obviously the image of B was 2 and 1. Okay. C was 2 and 3. The image of C is 3 and 2. D was negative 1 and 2. The image of D was 2 and negative 1. And then E is negative 3 and 1, whereas the image is 1 and negative 3. Okay. Yeah, so these are all points reflected along this line y is equal to x, and it makes sense if we look at the Cartesian plane, the diagram, the Cartesian plane, it makes perfect sense. Okay, so guys, reflection, I'm hoping you guys now sort of like have internalized the whole concept of reflection. It makes sense, you understand, you fully grasp. Okay. The one I did not, maybe Nwabisa may have also missed, was the reflection in the line y is equal to negative x. And what we said about the reflection along the line y is equal to negative x is that if you have coordinates x and y, the minute you have the image of A for reflection along the line y is equal to negative x, is that you actually swap your x and y around, and then you change the signs as well. So you swap, change both signs. You swap x and y, and then you change both of the signs for the coordinates that you've swapped. Okay? Okay. Hope that makes sense. Alright, let's move on to the next concept that has to do with anything, and that is enlargements. We have enlargements or reductions, if you want to call it that, where whenever a shape is enlarged or reduced through the origin, the coordinates of the shape move further away from or closer to the origin, thereby enlarging or reducing the original shape. The images are similar, but we talk about a scale factor. So enlarged or increased by a k factor. If you have a, which is x and y, the minute you enlarge or you increase by a certain factor, then what happens is that you are taking the x coordinate, you are multiplying by the factor of k, and then you take the y coordinate, you are multiplying by that factor of k. That's what happens when you are enlarging or increasing by a certain factor. You are enlarging the image. Okay. You can also reduce or decrease the image by a k factor or enlarge by a factor. If you can see here, it's a fraction here, 1 over 2. So if I'm going to, for instance, reduce by 1 over 2, it means I'm going to just multiply the x and the y coordinate by a half, all right, respectively. And then I get my new coordinates. So that's just it with enlarging, okay, by a certain factor of k. Okay, so I'm just gonna do an example here so that say triangle ABC has vertices A 1 and 3, B 4 and 3, C 3 and 1. Okay, triangle ABC has vertices A, 1 and 3, B, 4 and 3, C, 3 and 1. And the question says determine the coordinates of image A, image B, image C, the image of triangle ABC after and what? An enlargement by a scale factor of 2. So what do we do when we answer this question? Very simple. A, 1 and 3. The image of A, we simply do what? Enlargement by a scale factor of 2. 1 times 2, 3 times 2. What is the new image of A? 1 times 2, 2. 3 times 2, 6. This is the image of A enlarged by a scale factor of 2. Yes, guys, there it is. A image is 2 and 6. Let's see you guys lead me along with the B. What about B image? Yes, super not angel. Yes, Nobisa. Woohoo! Okay, you guys have got it down. Yes, 4 times 2, 3 times 2, 8 and 6. Very true. The image of B. C, 3 and 1. What about the image of C? Scale factor after an enlargement by a scale factor of 2. Yes, Mabisa. Yes, Mabisa. Yes, Mabisa. Yes. Okay. 6 and 2. Very good. Okay. I think we get the point, right? We get the point. Okay. And then if they say we must draw triangle ABC and triangle ABC on the same system of axes. Okay, hopefully we can do that as well. Yeah, hopefully we can do that as well on Sketch. Okay. Okay. Okay, let's first draw the first triangle. It was 1 and 3. A, B, 4 and 3. Then C, 3 and 1. Okay, right, so I'm going to connect. Okay, triangle. So hopefully when you can use your ruler and connect, guys. I'm just using this. Okay, so that's my first triangle. A, B, then C. How can you use that? B, sorry, 4 and 3. That's B. Then it's C here. Okay, then my other triangle, the one with the image, 2 and 6, 8 and 6, 6 and 2. So 2 and 6, 2 and 6. 8 and 6, 8 and 6. Then 6 and 2, 6 and 2. Okay guys, you'll be using a ruler, right? Just that I'm holding my phone with the other hand, you know, so hopefully you understand why I'm doing this freehand. Okay, but what do you notice? You see the enlarged triangle, and this is the point that we want to be able to see by actually sketching this thing, is we are seeing that, oh, okay, this was a small triangle. We enlarged triangle ABC by a scale factor of 2, and so you have a bigger triangle. In other words, these two triangles, we call them, according to geometry, we call them similar triangles. Why? Because the angles of these triangles would be the same, right? But the sides would be in the same proportion, right? The same ratio. Yeah, because we multiply each side by the same amount in order to be able to get the respective side. So yes, indeed, the image is bigger than the small one. Hence, we talk about enlarging or increasing by a certain factor. So if we enlarge, then this is what you can expect to see. Okay. Okay. I hope it's clear. Let's do something else here. Triangle ABC has vertices A, 4 and 6, B, 10 and 8, C, 8 and 2. Now we are told triangle ABC, the image is the image of triangle ABC after an enlargement by a scale factor of half. Determine the coordinates of triangle ABC. So there it is, guys. This is A, this is B, this is C. We are told that triangle ABC, the image, is the image of triangle ABC after an enlargement by a scale factor of a half. Determine the coordinates of the image of triangle ABC. Okay. So grade 9s, I hope, grade 9s and grade 8s, hopefully we can first establish what are the coordinates. So A, 4 and 6, have B, 10 and 8, we have C, 8 and 2. So for each image, what are we doing? 4 and 6. What are we going to do? Since we know that it is by a scale factor of a half, how are we going to determine the coordinates of triangle ABC, the image? We're going to times by half. Then the image is going to be, the half of 4 is 2, the half of 6 is 3. There it is. 10 and 8, the image of B. 10 times half, 8 times half. We get the image of B. What's the half of 10? Very good, super not angel, 5 and 4. Then lastly, the image of C. Four and 1. Very true. Super not angel is on the money there. Okay, nice. Okay, do we see? We just multiply each point by half. Okay, just like in the previous one, when it said enlarge by a scale factor of 2, we multiplied each point by 2. But now since it says enlarge by a scale factor of a half, then we multiply each point by a half. Okay, and then if we are required to sketch on the same system of axes, okay, I'll leave that up to you to do, guys. I won't do that one. Okay, hopefully you got the point. I did in the previous question, I did. So I'll leave that up to you to sketch the points A, B, C, and you know, the vertices for that triangle. And then you sketch the vertices of triangle A, B, C. And you should see something that this one is obviously a big diagram, but then since we are enlarging by a factor of half this time round, you should see that this is reduced. Okay, we are actually dilating, or in other words, we are reducing the what? We are decreasing the shape, the shape size. Okay, that's very important to note. Okay, the last thing I want to go over now is rotation. All right. Okay, I'm doing rotation for enrichment. Okay, to enrich your knowledge. Okay, just for enrichment. Okay, enrichment. We said that rotation is a turning movement around a fixed point by a certain angle. Rotation is simply what? A turning movement around a fixed point by a certain angle. So, if we look at rotation, we can look at rotation under these following headings. 1, we look at rotation 90 degrees clockwise. Okay, now if you are talking about clockwise, then obviously you are looking at the direction of your watch. Okay, yeah, so clockwise. All right, $90 degrees clockwise, and then there's 90 degrees anti-clockwise. Okay, then so that's 1, 2, 90 degrees anti-clockwise. 3, 180 degrees clockwise and anti-clockwise. These mean the same thing, right? Okay, I'm just doing this, guys, for enrichment, just for your own enrichment, you know, because when it comes to translation and transformation, these are some of the other things that are there. Then there's 270 degrees clockwise. Okay, and then there's 270 degrees anti-clockwise. You see? Yeah. So 90 degrees clockwise. What impact or what effect does 90 degrees clockwise have? So let's come here. Before your rotation, you have a point which is X and Y. If you say you've rotated this point 90 degrees clockwise, guys, this is the following result. X and Y, they swap. And then your Y coordinate, which has swapped, it changes sign. I mean, your X coordinate that has swapped, it changes sign. Okay. Okay, you can just change the sign and then swap. Does that make sense? Change the sign of your X and then swap. So, yeah. So, in other words, these swap around, but then the original X changes sign. That's all. That's what 90 degrees clockwise, well, that's the effect that 90 degrees clockwise will have. Okay. So, I repeat, 90 degrees clockwise, X sign changes, then we swap. So you see this X now, it's no longer positive, it's negative, but then these two have swapped around. Okay, that's what 90 degrees clockwise, the effect or the impact that 90 degrees clockwise has. Let's come here. 90 degrees anti-clockwise. Okay, so if 90 degrees clockwise had that effect, then 90 degrees anti-clockwise should have the opposite effect. Okay, so we are still swapping. Why does the sign change? Because it changes, that's why. That's what they say. Okay. And as I said to you guys, this is not like I don't think this is not actually included in your syllabus for grade 9. All right, I'm just doing this for enrichment, and I'm not going to do any activities on it. I'm just going to touch on it and leave it. Okay. The translations that are important I've covered, the ones that are important for the purpose of examination and so forth, but these ones are just for enrichment. It's for your own additional knowledge and information. Okay, I'm not even going to do, like I said, I'm not going to do exercises or problems on them. Okay, just important to note. Then 90 degrees anti-clockwise, Y changes, then we swap. Whereas 90 degrees clockwise, X changes, we swap. Y changes, we swap. X changes, we swap. Y changes, we swap. 180 degrees clockwise, 180 degrees clockwise. It's X and Y that change the sign. X and Y change sign. Okay, no swapping, just simply X and Y changes sign, whether it's 180 degrees clockwise or 180 degrees anti-clockwise. X and Y simply change sign, and that's it. And then lastly, 270 degrees clockwise, X and Y swap, but Y changes its sign. Okay, Y changes its sign, X and Y swap. 270 degrees clockwise, X changes its sign, X and Y, they swap. All right, so I'm just going to give you an aerial view of these notes. There they are. You can screenshot them, and yeah, you can keep them there. Okay, guys, that pretty much ends our live session for today. All right, for grade 9 transformation. Okay, for what? For grade 9 what? Transformation. Okay, so I'm gonna hold it right there. hold it right there. So I'll see you in the live lesson tomorrow morning, same time, same place. We'll start it off at 6. We'll end around about this time, 8 o'clock, 2 hours. I think tomorrow we'll be doing area and perimeter as we lay down the foundation for surface area and volume, which are term 4 topics. Okay, the sooner we do this, the better, so that we can actually get term 4 work out of the way, and we can start revising for the exams. In the live lessons, when schools open, guys, I will not be teaching term 4 work. If you want to get access to term 4 work, I'll save these live lessons. I'll post them onto the YouTube channel. You can go and watch the lessons as done previously, but that's what I'm intending to do. But for now, guys, hopefully you guys learned a lot. I will, like I said, download this lesson. I will save it there on the YouTube channel. If you missed something, you can go and watch it there, and you can learn and understand things that you didn't understand. Thank you so much. Have a good day. I love you a lot, you people here. And thank you for always being active, participating, and doing amazing things. I really appreciate you. Take care.